Looking at analysing a product through disassembly is an important stage in many design processes, whether you're reverse engineering, whether you're looking to make spare parts, lots of other uses. Now, rather than looking at something complex like a PC, this is something that hopefully is a little simpler. This is a remote control for a skybox, obviously a lot smaller than something like a PC. Not that it's not necessarily any less complex. Starting off though, before we even touch this, got to think about our sort of safety for taking something apart. This is a low power item powered by a couple of batteries, which we'll see when we start to take it apart. So the risk of electric shock is very low. The risk of static discharge issues for the circuit board that is no doubt inside is also relatively low. The only hazard that I can think of is the fact that there is no obvious sign of closures like screws, mechanical closures, on the outside, which suggests that, like many items like this, it will have to be separated by putting something into the sort of gap between the sort of the back and the front and levering, and the risk there is that I could slip and injure myself. So we have to think carefully about the direction in which we may be applying some sort of tool. Before I start to disassemble it, I need to kind of think about some of the things that I can see regarding to Access FM. Aesthetics, first of all, for the A. This is something that is designed to fit nicely in the hand. So the lower portion here is a little bit more bulbous, so that fits nicely in the palm of the hand, leaving my thumb close to the main dials and switches here, with also access fairly easily to the lower buttons. The less likely to be needed power button, for example, is a bit further away, so when I'm using a Sky device, I'm most likely to be using one of the controls just to move up and down to select things. I might be using the volume control. So those are things that are easily reached under the thumb. So we have to think about the sort of size of something. It's not too small. Small things with electronics make it a bit harder for the internal components, things like batteries. I don't want it too large, so it needs to fit comfortably in at the wide range of hands. So I've got a large number of customers thinking about the C on Access FM, the second C to the third one. First one, cost. These are relatively cheap to make. There's probably a very specific board inside that's easily modifiable to many different types of remote controls. The keys, this is all mostly made of plastic. We've got obviously some contrasting colours that makes for a nice aesthetic, and it's probably manufactured in a way, in fact it is, just feeling it, these are slightly raised so paint won't wear off them, which is a common problem on a lot of remote controls where numbers disappear after a lot of use. Actually making them raised, there is no paint to wear off, so it will always be obvious what particularly those ones are. Paint may wear off the numbers, but that's probably less of an issue as these are the main controls. Looking at the aesthetic, obviously we have round buttons. That's often quite sort of a nice shape to see. You may notice that on the 5 there's a couple of dots. That's a common thing that is used for those with maybe visibility issues. They can find the 5 and then know that they will move from there. So it gives somebody who can't see very well the ability to find a button. You sometimes find similar things on computer keyboards where you may have a little raised section on some of the numbers. For example, an F and J may have it, so one for each hand. Also looking at it from the kind of the outside, there's a number of measurements we could take before we start taking it apart. We could measure the overall dimensions. So using something like a 30cm ruler, we can measure the overall dimensions. In this case it is 175mm long. This is curved, that does make it a bit harder to measure. So It might be something that actually, as mentioned previously, using a scanner with a ruler, you could then importing that into CAD software, you may be able to get a better idea of the size. We could also lay that over, and viewed from directly above, we can actually then take a measurement of that, and that actually does make it look a bit longer. The camera can deceive sometimes a little bit when we're using this, so it's important to sort of make a decision about how am I going to measure that. Width, in this case, something else that I record, about 47 millimeters. Now, rather than using the ruler on that, I could use the I could use my caliper. So make sure that it's reading 0 with a certain amount of pressure on it, and then I can move that either side of that, making sure it's level. 48.97, so 49 millimeters wide at that point. This particular caliper is not long enough to get the overall length, but we could use it to measure the positioning of the buttons, for example, the size of the buttons. So we can measure the diameter. They're slightly proud. Again, that's an aesthetic design. So about 8.3 millimeters. You could call that 8 millimeters if we were designing our own. If we're trying to make a replacement part, we need to be more exact, and it might actually be easier to measure once they've been removed. We can see that some of the buttons are slightly smaller, so that appears to be about 7 millimeters. Again, it's hard to get an accurate measurement, so it may be easier to actually do that once it's dismantled. We have, thinking aesthetically, we have obviously some colours on there, and that can be useful in terms of identifying buttons for easy use. Materials wise, this is plastic, it's almost entirely plastic. It's possibly an ABS plastic, although without seeing more details it would be hard to tell. So we'd be looking for example, the recycling triangle, because that's a way of identifying plastics, because there are lots of different types. Size-wise, size-wise, obviously we've just measured that. Environmentally, it's plastic. Thinking about the environment that it's going to be in, sometimes these are sealed so that if somebody was to spill a cup of tea, for example, on the remote control, then it possibly wouldn't cause too much of an issue. That makes it a little bit more expensive, so it's also common for that not to happen. Function, well, its job is to change channels, to change volume, to set recordings, etc. So it's got a lot of function, and that's mostly controlled by the electronics. Materials wise, we have the plastics. Inside there's probably circuit board, we will find that out. Manufacturing, this will of course be mass produced, so this will be produced in very large numbers, and it's mostly going to be by injection molding. So let's start by actually sort of dismantling this. The first thing with any device like this is to actually remove the batteries. Now this is just a quick slip case, and we can see that we have a tab. It's actually a locking tab, so pressing down on that helps to remove that. We also have here a couple of slides. So underneath this section here, which is hard to show on the camera, it's designed to slot into these two slots here. So when it's forward, so it will locate there, and then when it slides forwards it cannot lift up at the back. But pressing down to disengage the lock here and bringing it this way does release it. Now there is some information on the inside, and it's very difficult to see on camera, but it tells us that obviously it's a Sky device. We have an address for the United Kingdom for the supplier. We have some codes, we have a model number. What we do not have is any form. It tells us it cannot be recycled. So it might therefore be a nylon reinforced plastic that generally makes them strong but does make them unrecyclable. This particular shape, I could use a profile gauge to measure the radius of this curve. I could use if I haven't got one of those and haven't 3D printed one, then I could just draw a series of circles with a compass, a pair of compasses that you might use in maths for constructions, variety of different sizes, and then just take that to the circle and compare the shape. Got a little divot here which appears to be just under a centimetre wide. Yeah. If you're dismantling something, again, depending on your context, your purpose, so yeah, it does appear to be a centimetre wide. Whether you would measure details like that or whether you would consider them for your own models depends on the context, the nature of the clientele. Similarly, the thickness of this I can measure with my caliper. It's about 1.9 millimeters thick, maybe 2 millimeters. Obviously, the thicker you make it, the stronger it will be, the heavier it will be, which may not be necessarily good, but also the more expensive because you're using more plastic. If I make it thinner, I would probably make it cheaper, but I might have to design in points to make it strong. We have the battery. Batteries are easily removed. It's a fairly standard type of connectors involving some springs. These were two AAAs, so this will be a standard size compartment. We also have a little feature here which is quite nice, two little flexible clips. So we can see that they're shaped here and they're able to move, and when you put the battery in they will just move to the side, but then they will hold the battery in place. So when a remote control maybe gets dropped on the floor because your cat's just jumped on your lap, the batteries aren't going to shift and stop the device from working. Now sometimes when you look inside the battery compartment you might see some sort of fastener. I cannot see any inside here, which suggests that there isn't. So the most likely way that I'm going to be opening this is to actually get something inside the gap here and separate the top from the bottom. I could use a flat-headed screwdriver and that would probably work quite well, making sure my fingers are not in line with it. I can see there's some flexibility. I could also use a device like this. This is what's called a spudger. They come in all sorts of different sizes. Some of them look a bit like guitar picks. Some of them have can be made from plastic. Some are made from metal. This one's metal with a plastic outside. And these can be forced into gaps and then actually sort of moved along. So that's already separating there. I'm going to flip it over, go from the other side. So if I'm writing a procedure from this, I would be thinking about, well, what's my starting point? We can see this is it's quite dirty, it's very old, it's actually stopped working. So like many things, there's often collects dirt in points where you wouldn't necessarily see it. This is well polished from lots of use, but we still get dirt built in there. So design wise you might want to not include something that could collect dust, but it would make it harder to assemble. You might want to make it so that it's completely smooth. Assembly becomes hard, disassembly even harder. So I'm going to separate that out. Now sometimes these will only go so far before they need a little bit more force. And so far this seems to be coming off fairly easily. A little bit of movement on every side is often the way to approach rather than lots on one side. So I've taken that off and we can see actually underneath here the structure we've got. Now the fact that this has these ribs inside does make it easier for us to measure. So we could actually sort of measure the spacing between those. If I want to get the height of each of those ribs, then the ruler's not going to fit inside. You could use something like a screwdriver or something like that and just use your thumbnail to mark in how far it's gone and then compare that to the ruler. Or I can use, this one we should be using, our caliper, and we use the tail of the caliper, and I can actually put that inside. See, I've gone too far there, so I just rest that back until that's level with the piece I want to measure against, and then I can read, and I can see they're 3.4 millimeters deep. But they will vary. Just a visual inspection tells me that it's very shallow here. You can tell by the shadow, and it's much deeper over here, because overall this is curved, and that does make for design a little bit harder. But you'll see that internally it's flat along this section. Things with curves are harder to model, particularly if you're modeling somebody else's, but it's not impossible. We have these registration pegs that are also help holding it together. So we have 4 on each side. One has broken off. I can see that it's actually broken off, and that's probably as a result of it being dropped at some point. Now I'm inside, and I can actually see the keys a lot more clearly, and therefore it would be much easier for me to now make a measurement of the diameter. So actually 8 millimeters is a better diameter, and 7 for those. Now this piece might be hard to tell if this is actually in, or looks like it's in one piece, and that might lever away, and we'll find out. Interesting, looking on here, I can see that actually 2 more of the pegs are broken. So one is broken up here and 2 are there. And so it's not just the 7 I have here, 4 on this side and 3 on that side. Altogether there should be 4 on each side and 2 at the bottom, so 10 in total. So if I was trying to make a replacement for that, maybe for example a client wanted that in a different colour, then I would need to make sure that I include the locations on the back as well. With all the posts, I can measure the dimensions of those posts. In this case 2.5 millimeters, 2.55, 2.6, depending on my manufacture technique. I might want to make them slightly smaller so that they do locate, and I might even want to then think about using glue. I'm going to see if the top section will remove as well, and these buttons do appear to loosen up. I'm going to go for this section here, and I'm hoping it's a similar sort of pin. You often find that when you take something apart, the technique that's used by the original designer on one part will be used on another part. Not always the case. Sometimes they want to have different techniques, but yes, it does appear they're using location pegs. So this time we have 4 that are going to go into holes on this side, but we've also got 2 here that go into holes on there. Just makes it a little bit more secure. You'll notice that there's a cutaway for the sky, which is on this bit here. From a design point of view, I'm not quite sure why they've done that like that rather than moulding it in there. I suspect it probably is that was injection moulded, and it was easier to injection mould that without the 2-colour part that's there. But again, we can use profile gauge in order to get the radius. So I've already pre-checked this one. It's 24 millimeters. You might just be able to make out 24 on there. Again, we could do that with a compass if we wanted. So I've removed those sections. I can make measurements of those. I could scan those. I can take the measurements from the back. Now this actually is quite useful. It does actually tell me that this is made of ABS. So it's just written there, ABS. From a 3D printing point of view, ABS is quite tricky to use. It gives off some fairly noxious fumes if you try and 3D print it. It requires quite high temperatures and a very good setup on a printer. So we have the basic material there. Now still at this point I can't see any mechanical fastenings, for example screws, but I can see that there appears to be some posts sticking through, so it might well be that actually things start to fall in. There we go, actually there we have it. This is quite interesting, this corrosion here, this, as I mentioned, this is old. This tells me that this was some point the battery has decayed inside the remote control, and that has caused some damage. Again, from a structural point of view, we have these ribs inside. This makes it something that instead of being flexible is very strong, in a similar way that the PC case had the folded edges. By having these ribs inside here, for very little extra material you get something that makes it much stronger, but without adding too much weight or too much material. Obviously we can see here where the catch goes in from the back, so if I put that into there, slide it forward, we can see it come through here, and we can't quite make out where the gaps here and here are for the battery lid to engage with those holes. So now I'm down to the circuit board, and the level that we're at the moment, we probably wouldn't take that much further. But just a quick look at this. We have two battery connectors here. One part of the battery connector is still inside. This is just a spring connected from this side to this side, and this just basically takes the battery, which were arranged plus to minus like that, and it is the same as having the battery, one long battery, arranged that way. And you might have remote controls at home where sometimes the batteries are arranged like that and sometimes the batteries are arranged like that. From a safety point of view, if the batteries have decayed, it's very important to remove them carefully and dispose of them carefully, and if you get any of the material that's inside on your fingers, to wash your hands really quickly. It can be quite corrosive. The inside of batteries can sometimes be very acidic or sometimes very alkaline. Neither are particularly good for you. If it feels greasy, it's alkaline, and that's what my fingers are feeling right now, because that is an alkaline battery, which are often long life. The circuit board, I can possibly separate the keys a bit further, but giving it a sort of a big pull, I can actually see it, that white there is an indication that that's actually starting to tear. So I'm not going to take that off any further. It probably means that these keypads, which I can see have been formed in two parts, we've got this zigzag here, that helps with location. This possibly will not separate. It might, if I'm very careful. So it will separate, and we can see the switch structure inside, but I don't think there's anything to be gained right now from taking that apart further. We obviously have more switches here, and these have been integrated into the device itself. So again, to remove those would probably be destructive, and I don't want to particularly do that right now. I'm interested in this Sky logo. It does appear to be flexible. I cannot see anything kind of sort of poking through. If I pull at it, it's definitely, yes, it's actually integrated into the plastic. You may not be able to see on camera, but when I lift it there, I can see that it's actually joined onto the plastic, this rubber like plastic that the buttons are connected to. I do suspect that the buttons are made in a couple of different parts, and that if I was a little bit of effort, I might be able to separate the buttons from it, but they may be glued, so that maybe I don't want to do that. At the top, these two little bits here, they're light emitting diodes. They're probably working in the infrared, so you wouldn't see anything coming from them. Although if you're at home with a mobile phone and you point this at the camera on some mobile phones, you'd be able to see them flash because they're in the near infrared. And they are used to transmit the information from the remote control to the receiver box used for this. The circuit board, you'll notice, is something that looks quite regular shape. We have some notches which are for locating with the cases here, so they will match up some of those location pins. See there, we can see how the notches, each one of those. Again, I could use profile gauge in order to find the diameter of those, or I could slide a drill bit into those to find the size of that. I can measure the board, and from the sort of activities you might be doing, actually kind of knowing the border dimensions. So that's 4 centimeters nearly all the way along at its widest point, exactly 4 centimeters, which does not surprise me. This is probably made in China or Singapore, Taiwan, all countries which use metric. I can measure the overall length, but the shape does vary there, and that's less critical. We do have these rounded sections. Again, the profile gauge will tell me the radius of those. So if I wanted to take this part, the functional part, and put it into a different housing, then I would need to know the size of that board. And that's a project I've seen a number of people do, where they actually try and change the thing that something's located in. So for example, if they were a fan of Star Wars or Star Trek, they might want to make it look like it's something from the Star Trek or Star Wars universe, but keep this with its function. So that would be fairly easy to do. They might actually sort of cut the Sky logo off, because that would be possibly the only way of doing it. Although I do notice, this is actually something that somebody else gave me. I don't use a Skybox. I've just realised, and this explains why there is a gap here. There's actually a switch underneath there. So if you've got a Skybox, you might know why that is. At the moment, I don't. If you ever see me again, you can tell me why that is. So that's the disassembly, and if we want to put that back together, then as long as we've remembered all the order of the parts, and with something like this there's not too many parts, then we can pretty much just push it back together, because there were no mechanical fastenings, only these push fit fastenings. So with a relatively even pressure across the different parts, I can probably put the batteries back in and we have it back together again. Take apart any remote controls at home at your own risk. There we go. Hopefully that's helpful. In terms of procedures, I would make measurements as I'm taking them down. I think about, first of all, the safety. I think about the steps, starting with an inspection, visual inspection and measurements on the outside before disassembly. Each stage of the assembly, taking measurements of each part as we go along. I might take photographs, I might use a scanner in order to get the shape and import that into my CAD software. All depends really on the particular context and application you might be dealing with. And if you can, put it back together again. That's it. Thank you.